This lesson covers some maths principles that you may need to be aware of. Here we have a series circuit consisting of a resistor and a capacitor. The current through each component is the same, so we'll consider this the reference. The voltage across the resistor is in phase with the current. The capacitor is a reactive device, which means that it stores energy and returns it back to the supply. It doesn't dissipate power. The voltage across the capacitor lags the current by 90 degrees. The relationship between the voltages of the circuit can be seen with a vector diagram. The vector diagram consists of the real number line and an imaginary number line at right angles. The vectors are considered to be rotating anti-clockwise around the origin. The current is the reference and is at 0 degrees. The voltage across the resistor is in phase with the current and is at 0 degrees. The voltage of the capacitor lags the current by 90 degrees, so is shown at minus 90 degrees. The supply voltage can be calculated by completing the square and determining the magnitude of the diagonal. The voltage can be represented in two ways. Polar format, which is the voltage and a phase angle. The phase angle in this case is negative. Rectangular format, which is a complex number, which consists of a real part and an imaginary part, with a prefix j, which is often called operator j. The vector diagram can be used to represent resistance, capacitive reactance, and impedance. Here we have a series circuit consisting of a resistor and an inductor. Once again, the current is the reference. The voltage across the resistor is in phase with the current. The voltage across the inductor leads the current by 90 degrees. The vector diagram shows that the voltage across the inductor is a positive J value because the voltage is leading and the vectors are rotating anti-clockwise. The phase angle is positive. The vector diagram is showing the relationship between resistance, inductive reactance, and impedance. Here we have a series circuit consisting of a resistor, capacitor, and inductor. The XC is negative on the imaginary number line, and the XL is positive. When working out the impedance, you subtract the smaller magnitude from the larger, and the circuit can be considered to be predominantly either inductive or capacitive. The value of the inductive reactance and capacitive reactance will be the same at one particular frequency. The two reactive values will cancel each other out, and the circuit will be only resistive. This is known as resonance. This method is used with power factor correction. A motor that is predominantly inductive can have its power factor corrected by adding a capacitor. The area of a shape is the multiplication of two linear magnitudes together. With a rectangle, it is the length by the width. It is important to change the values of both measurements to the same units. The unit for area is square meters. The area of a circle is pi multiplied by the radius squared. Three-dimensional objects are the multiplication of three linear measurements. The unit of measurement is the cubic meter. We generally use the base 10 numbering system. It could be because we have 10 fingers. The value of each column of numbers is a multiple of 10. We have the units column, tens column, hundreds column, and thousands column. With this number we have 3,000s, plus 700s, plus 6 tens, and plus 4 units. 1,000 can be represented as 10 cubed. The exponent 3 indicates how many times 10 is multiplied by itself. Any number raised to the power of 1 is the number itself, so 10 to the power of 1 is 10. If you raise any number to the power of 0, the result is 1. When you multiply numbers, you add the exponent. For example, multiplying 100 times 1000 is the same as multiplying 10 squared by 10 cubed. Add 2 to 3 and the result is 10 to the power of 5 or 100,000. When you divide numbers, you subtract the exponent. To divide 100,000 by 100, subtract 2 from 5 and the result is 10 cubed. With the base 10 numbering system, 10 to the power of 0 is 1, and 10 to the power of 1 is 10. Any number between 1 and 10 can be represented by an exponent between 0 and 1. These are called logarithms. Numbers between 10 and 100 will have a logarithm between 1 and 2, and so on. To multiply numbers, you would add the logarithms together. Logarithm tables can be used to convert numbers to logarithms and back again. One important thing about equations is that the left-hand side equals the right-hand side. Whatever you do on one side, you must do to the other, so that the left-hand side still equals the right-hand side. For example, we have a formula for the volume of a cylinder. We want to rearrange the equation to determine the height when we know the volume and the radius. Divide both sides by pi times r squared. Height is the volume divided by pi times the radius squared. The axis of a graph has arrows to indicate that the values are part of the number line and continue on. The horizontal axis is the input or reference, and the vertical axis is the output. Show the units of measurement on both axes. Mark the graph with the coordinates from the data table. The data table should be shown in the vicinity of the graph. If the line can't easily be drawn, then just show the coordinates. Otherwise, draw a line.